So today is going to be kind of a short day. I know this is probably going to break your hearts. Um, Looking at the homework, I asked you all to make a statement on Wednesday. Most of you got that statement turned in about the gases. We're gonna do one little lab with one gas. I'm trying to acquire some more. I want to try to get some helium uh, and a couple of other gases on that list that we can kind of experiment with. So let's see here. You really like long days, Buvia? I'm sorry. I can give you a bunch of reading to do if you want. All right, looks like
Maybe you can just look like random experiments that we can do at home.
I would have to think about that. I mean, the best thing to do is actually just to Google some experiments. So what we're going to be doing today, and see, I don't know how many people, a lot of parents don't like their kids playing with fire. Yeah, that's one thing. Hey, Merrick, it looks like you got your ears lowered a little bit.
Oh yeah, I got a haircut.
Looks good, sir. Looks good.
Thanks.
All right. So we were talking about some gases last week, and one of the things that we did is, I took a beaker. Let me grab a beaker. I have a beaker right here. I'll go ahead and go full screen here. So 0.2 seconds, huh? That's pretty quick. Oh boy, we got a bunch of comedians today. All right. So the beaker, wow. Okay, up I go. Let's see, anything else I'm going to need? Let me get my bath bombs over here. All right, so I showed last week that if I light my match and I stick it into my beaker still burns, right? Or the match still burns, my beaker doesn't burn. Now, if I hold the beaker, the flask, excuse me, upside down, is it still going to burn?
No, it's gonna go out.
Okay, but you just saw me put the match in the beaker, and I keep calling it a beaker. I get the match burning. I mean, it still burns, right?
Yeah, but when you light the match, it burns through the chemicals in the air, and the stuff in the air wants to rise. But when the beaker is turned sideways, there's still enough space so that when the chemicals rise, it can move. Like the chemicals can still get out of the beaker. But when you turn the beaker upside down and light a match in there, everything rises, but there's no room to leave, so it all stuffs out the kindle. So it basically needs oxygen, and once it burns up with the oxygen, it just goes out.
Okay, so would that mean the oxygen itself is lighter than the air? Because is the oxygen going up and just staying in there? And the air won't go up inside there?
I think there's no like more air. If you block up the air from coming in,
Okay.
there's not enough
Now,
oxygen.
I did put on Google Classroom a chart that I think I shared with you. You know, oxygen is 1.4 grams per liter, where air is 1.16. So which is heavier, the air or the oxygen? If oxygen is 1.4 and air is 1.6.
The oxygen?
Oxygen.
Right, so if it comes out of this bottle, there's nothing replacing it, right? The oxygen is not going to go back inside there. Does that make sense? Because the oxygen is going to fall to the ground.
Yes, sir.
Now, there is oxygen in air. You know, that is part of what air is. But there's only 20%, so there'll be a lot of other gases trapped up inside this flask than the oxygen. But you're right, you know, when I do turn it over, it burns for a second. And then is quickly, well, not quickly, but it is extinguished. Now, can I light another match and put it in there and let it burn for a few seconds?
No, I don't think so.
I mean, teeny bit of time. Yes, Mambitha, you may go grab a water bottle. So it goes out pretty quick. Now, get some more air back in the bottle. You know, it's so if I pour some water in the bottle, and I got a fresh inflection of air in there. You know, my match burns inside the bottle. Not a problem at all. Because like I said, match was still burning and I set it on my desk. I'm keeping the flask at an angle so air and oxygen is going this way with no problems at all. Okay. So, and this is just kind of a repeat of what we did last week. But if I go ahead and drop some bath bombs, glass that's been burned for a little while is hot.
I'm pretty sure anything that's been burned for a while and stopped being burned is going to be hot.
All right, so as soon as this match gets close to the beaker, it starts to go out. But I pull it away, and sometimes it lights back up. So I have a gas being produced by my bath bomb that will put out fire. All right, what's going on here? Looks like we got some kind of, hopefully no drama here. Let's see. Light is air, oxygen. So when we breathe oxygen or air. We breathe air. So we have no choice but to breathe air, Vedant. When I breathe in, every breath I take is over 70% nitrogen, about 20% of it's oxygen, and a whole bunch of other stuff. I'm breathing in pollen, I'm breathing in dead skin cells, I'm breathing in carbon dioxide, I'm breathing in water, I'm breathing all this kind of stuff. But, Vedant, and anybody else, our body only uses the oxygen. That's the only thing that is actually being breathed into our body. So we breathe in air, we breathe in all kinds of stuff, and it's getting kind of nitpicky. We say we breathe oxygen. Well, we breathe everything, but our lungs will only absorb oxygen. Does that make sense?
Yes, sir. So it's kind of like a filtration system?
Yeah, I am sure to some degree, possibly there are some trace gases that come into our body. I mean, that's why we can breathe a poison gas and it kills us. Okay. If only oxygen entered our body, then you could walk through a room of poison gas, and the worst thing that could happen to you is you suffocate. So there are other things that enter our body, but oxygen is what our body needs. That is what pulls everything in. Yeah, air is complicated. Air is a generic term. When we say air, we think of, well, we need oxygen. Irradiated, where's that coming from? Irradiated means that we've killed things. You've used radiation to neutralize biological agents. Um, but when we're talking about, yeah, we need air to breathe, we're basically saying we need oxygen to breathe. It's just like saying I want to use a Q-tip to clean my ear. You want to use a cotton swab. Well, maybe you want to use Q-tip. Maybe you want to use that brand. Air is a generic name, is saying for everything that is in the air that we breathe. Okay. Anyhow, does that kind of make sense, Vedant? Anybody else that might be a little bit confused with that subject?
So basically, oxygen is part of the air, and we don't breathe air, we breathe the oxygen in the air.
Right. And the thing is, oxygen is actually a small part of the air. I mean, it's 20%. In a whole, it's only 1/5 of what we breathe into our body every day. When we take a breath, only 1/5 of that is something that we use.
Well, if I had a saying when I could breathe, I'd breathe something that's very common.
Manvitha, what do you mean I used radiation in the wrong way?
Oh, that was for Avinash's question about Avinash's question about irradiation.
No, irradiated. And that is an actual word. If you irradiate something, you're using radiation to kill something. We irradiate cancer cells with radiation. So, do we intake water, or is that one of the things that's actually filtered? We take in water, but now water is something that is, so the lungs are what is basically limiting what we breathe going into our body. Our stomach is where water is absorbed through, and that's a lot different. Anything in that water we will take into our body with it. Our stomach is not so picky, I guess you might say, as to what it will take in, because it's taking in nutrients from all kinds of different sources. Again, it more than just oxygen though comes through our lungs, but that's the primary thing that comes in. There are other gases that do come in, but that's the main thing, is just oxygen. That's why I was saying we can breathe in poison gas, which contains more than oxygen to kill us. But a lot of things don't enter our body. I don't believe carbon dioxide comes in. I don't believe, I just kind of lost my thought. I don't believe we breathe in water in there. It doesn't actually enter our bloodstream through the lungs. So there are some molecules, I think it has to do with size, that is prevented from coming into our lungs. Anyhow, let's get back onto this topic of trying to figure out what gas is in our bath bombs. Okay. So, let's see here. Miss Markham, are you with us today? I don't have the roster in front of me. All right, let me pull up the list of who's here. Miss Markham.
She is here. It shows on the.
Yeah, I see her, but she's not responding to me. Yes, okay. Oh, there you are. Okay. Miss Markham, tell me what gas or what combinations of chemicals, ingredients that we use produced gas in the bath bomb? Okay, you have your notes. You can look in your notes. I mean, you should have your notes right in front of you. Do you have your notes in front of you? What do they say? It'd be a lot easier if you could talk with us, Miss Markham. Okay. Reese, how you doing, young lady? Good. So, Reese, how about you? What ingredients produced a gas in our bath bomb experiments? And if your mic is messed up, you need to go contact tech support so they can either get you a new computer or fix your mic. Are you looking? Okay, well, we didn't have an ingredient, carbon dioxide. Okay, let me ask Samuel.
Yeah.
All right, so Samuel, what ingredients did we use in our bath bombs to create a gas?
Baking soda,
Okay.
citric acid, lemonade, and baking soda.
Okay, so lemonade and baking soda or citric acid and baking soda. Very good. So, and the thing about lemonade was able to do that because if I looked at the ingredients of lemonade, it has citric acid in it. So by process of elimination, we know that citric acid produces a gas. So what I'm going to do is, we know that citric acid, or we know that the gas in the bath bomb will put a flame out, correct? Anybody?
Yes.
All right. So if I know that, and I make a little concoction right here of baking soda, citric acid, and some water, and I seal it in my Ziploc baggie, and I produce a gas, and it is quite a full bag right here. When I open the bag, this is not being very cooperative to me. My match does not go out. Okay. So does that mean my gas is more dense or less dense than the air around it?
Well, I think it's less than.
Right. Yeah.
Okay, if it's less dense, when I open the bag, shouldn't the gas have came out and put out the flame?
Well, it did, but I think you might have waited slightly too long
Okay, let me.
to where the reaction was over and the gas had already been.
All right, fair enough, fair enough.
It could be a gas that increases the flame.
Doubt it, because the lower the matchstick went towards the things inside the bag, the smaller it got. So I doubt that it would be something that powers that empowers.
Well, okay, see, the thing is, if when I lowered the match into the bag, yeah, the flame started to go out. But if the gas is lighter than air, shouldn't the gas be coming out of the bag? All right.
Yes.
Yeah.
So then it's more dense if it.
Mm,
This is
no, I
really
don't think.
this is really difficult with one hand. Okay, so here we go.
The lower you put it in, the like it extinguish. The lower you put it in.
Okay, so look at my bag is open and my flame is burning. Ow.
It's burning towards your hand.
Okay, so let's try something else and see how well this works. So I got a bowl here, and I'm putting what's called a tea candle in there. I'm going to light the tea candle up.
Why is it called a tea candle? Do you know?
Because they originally were used underneath teapots. So you would burn the candle under a teapot to keep the tea warm.
Must have cooked pretty slowly.
All right. So can you guys see that the candle is burning on the picture?
Yes.
Can't really see it. Maybe I should pin your presentation. Not whatever. I'm sorry.
I am pinned. You don't see it?
Well, it's not really clear for me.
I just pinned his screen. I can see it really clear.
Yeah. For me, it's a bit blurry. The vision itself, it's a little laggy. But that's all on my end. So.
Does that help at all?
On my end, it just looks like a big white blob sitting in the bowl. So.
You see, I really can't.
Pin his screen. Yeah, you have to pin his screen for it to work.
I did. It still just looks like a giant white blob.
Okay.
Except it's more restricted than it was before.
How many tabs do you have?
How many what?
Tabs.
Now I can kind of see the flame.
Right, let me try this here.
Okay, I can't see the flame, but I can see the bowl, even though it's half of it.
What if I do? Does that help?
Yeah, that does help.
Can you move
So
the bowl a little bit more forward? I can't really see.
put it more forward.
Yeah. Yeah, that's better. Thank you.
Okay. So what I'm doing is I have another concoction of citric acid and baking soda. And I am going to create another reaction. And this time I am going to notice how the flame just went out.
Yeah, what happens?
Okay.
If,
So
No.
this time I'm going to do this a little different so you can see it better. Let me rinse my bag out.
I couldn't really see the flame. Like, I can only tell that it went
Yeah,
out.
all
But
all I could see was the smoke.
Okay.
I didn't see anything.
So I'm going to light the flame back up. First, I'm going to take this out of here. I'm going to take my bowl, turn it over, my candle back in there. All right. You can see the flame burning, correct?
Yes.
It actually looks like it's burning a little bit better. Okay, so I'm going to make my concoction again. Baking soda. Citric acid on one side. Water on the other side. All right. So I mix my thing and the bag is open and the candle went out. No liquid in the bowl. The open bag is just above the bowl and it puts the candle out.
It would be more dense then because it's
Yeah.
spilled out.
Okay. And that, I mean, did everybody, I know this is not the best way to see all this, okay? I get that. I mean, if you were here, I mean, here's the deal. If you have access to a candle that can fit inside of a bowl, all right? If you have tea candles, which your parents may have them, and you can mix baking soda and citric acid if you have it, you know, you can do the same thing, kind of pour the gas into the bowl and you will see it extinguishes the flame. You know, I really wish we could all be right around this. I wish I had a better video system, but you know, I got what I got. It sounds like most of you were able to see it this time. I think, yes. If not, the video will be posted online when we're done here.
Mr. Schillinger, I have a question.
Yes.
I was able.
Would there be any way you could like put the reaction like in the bowl with the candle like very close next to it?
Well, we could try it. Let's see. Let me, all right, so my candle is lit. And let me get some more water. Put some baking soda in there. Put some citric acid in there. And then so put the candle right out. So
Right. What it could be.
I am making enough gas that it's going up higher than the top of the candle. But like Samuel said, and so did some of the other ones, Samuel was just the last one that, well, Sanish, we do. Because when I opened the bag on the side of the bowl, basically what happened was when I opened the bag like this next to the bowl, the gas came out but then went down. So if it went down and extinguished the fire, like Samuel said, Sanish, is it less dense or is it more dense?
More dense.
It's more dense. It's AKA heavier. There is more stuff in a given amount of space. So it's falling down into the bowl. So now, by process of elimination, if I come up here and I present my screen real quick, and I look at this chart, loading, loading, loading. Can you all see the chart?
Yes.
Okay. And this chart is also, I've already uploaded into the Google Classroom. So anything that is more dense than air, 1.16, which is right here. Excuse me, I said that anything the opposite way. Anything that is less dense than air, we can eliminate right now. So we know it's not carbon monoxide. It could be propane. We know it's not hydrogen. We know it's not methane. We know it's not helium. We know it's not neon. It could be carbon dioxide. It could be argon. It could be oxygen. And it could be nitrogen. Okay. So then out of what's that?
We could eliminate the ones that increase the flame because it extinguishes it.
Very good. Thank you. That's what we're going to look at next. So we can eliminate out of these, we can eliminate propane. We could, well, it could be carbon dioxide. It could be argon. We could eliminate oxygen, and it could be nitrogen. So now we have 3 different gases that it could possibly be. Okay. So I'm going to stop presenting my screen. Come on.
Couldn't we eliminate nitrogen too, since it's less dense than air?
It's more dense. Air is 1.16.
Oh, never mind.
No problem. I mean, I just want to make sure you see this. That stupid thing is in my way here, but yeah, if we look at it, air is 1.16 and nitrogen is 1.2. So it's just a little bit more dense than the air. But here's the deal. Here's the big thing to look at. How much nitrogen is in our atmosphere?
78%.
That's a lot of nitrogen. If the gas was being produced, I mean, yes, it will still extinguish the flame, but we're already around a lot of nitrogen, aren't we?
Yes.
And it's not that much more dense. So, I mean, we got to kind of investigate nitrogen, argon, and carbon dioxide. So this is where we're going to stop for today. We've done some basic exploring. I'm stopping my presenting. You can revise your statement if you wish. Okay, what's going on here? I can't see the chart. Wow, you guys, Shrey, why do you feel bad for the candle? Okay, now we don't know if it's dense or not. Okay, we covered that one. Out, brief candle. More dense, more dense. I'm just looking through the question to see if there was anything
I have a question.
Yes, sir.
So, are we gonna use the statement later in a CER?
No. This is for me to see where you are sitting on what you're thinking.
Okay. Are you supposed to like revise it on today, or?
If you'd like to revise it, you may.
Okay, thank you.
Wait, so if we think the same thing, we don't have to, or we don't have the option like to revise?
No, you have the option. You don't have to, though.
Yeah.
The statement was not is not going to be a weighted grade.
Okay.
So if your statement was wrong, that's fine. And like I said, that your statement is not any kind of evidence for a CER. Yeah, I'm a little bit behind on getting things in the grade book, but right now, Sanish, everything that's in the grade book are lab grades. As long as you are completing the work, like as long as you turned in the statement, you're getting a lab grade for those, because that means you were present. You saw what was going on, and it's giving you a chance to, right now that's all we're doing. We're just carrying out investigations right now. So yes, it's not in there yet, but it will be. That's what I'm going to be working on after we end this here in just a few minutes. So hopefully that answered everybody's questions. Don't forget, you have a little less than 2 weeks now on your Genius Hour. A couple of you asked me some questions over the weekend. I think I answered them. Send me a message if you need to on them, and I will address them as needed. With that being said, ladies and gentlemen, have a very wonderful day. Hopefully it doesn't rain too early. It's supposed to rain tomorrow, but it's a beautiful day outside. It's Temperature's like perfect. Am I okay? I am very good, thank you.
Bye, Mr. Schillinger.
Bye.
Bye. Have a great day.
You do the same.
Bye.
Bye. Oh, yeah, no. Believe me, I've burned myself a lot worse than that. I've actually picked up molten aluminum before and gave myself very severe burns on my hands. That match, it stung a little bit, but I'm fine.
Bye.
Bye. You guys have a wonderful day. Yes, that did hurt very much. But me and my son, we have a forge. We play with